Hello guys, welcome to our YouTube channel, The IT Man, and let's solve problem of the day today, magnetic force between two balls. Okay, so here in the problem statement, we are given an array called positions, and for the ith position, the value at I is the distance of the position. So let's see an example. So yeah, so this is what the position array looks like, and the position is specified that where at what positions we can place magnetic balls. So what it says is we have m balls and we need to distribute the balls into baskets such that the minimum magnetic force between any two balls is maximum. So it sounds like a bit confusing statement, but okay, so let's look at the example and understand the question better. So what it says is, like, let's say we are given a position array 1 2 3 4 7 m equals to 3. So let's go to the whiteboard. Cool. Okay, so we are given an array and it says 1 2 3 4 and 7. So these are the positions in which we can place our magnetic balls. How many balls we have? That's m. Now we need to maximize the magnetic force, even like the minimum should be the maximum possible we can achieve. Now okay, now let's try to visualize it. So let's say 1 2 3 4 5 6 and 7. Cool. So I have three balls. So let's say, okay, let me index it for you. 1 2 3 4 5 6 and 7. Cool. Now we can place a ball here, 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 here and here. Cool. Okay, so let's assume I place one ball here. Okay, now I'm left with two balls and I have to place it in such a way that the distance should be, the minimum distance should also be maximum. So let's say I'll try to place the ball here. Okay, now what's the distance? According to the problem statement, the distance is mod of x minus y, where x and y are the distance. So here it becomes 2 minus 1, which is equals to 1. Okay, can we do, and of course if the minimum distance is 1, so like we can place it at a distance this or more than this. So let's say I will place it, like I can place my third ball at a distance here. So I have placed all my three balls now. So till now I am able to achieve a distance of 1. Okay, let's see if we can make this better. Cool. Okay, fine. So distance 1 was possible. Let's check for distance 2. So 1 2, let's say I place a ball here. Now now whatever next balls I place should be more than this distance. Okay, so let's say I place it at 1 2 3 and plus 2, so that would be 4. I can place it here. 5, there I don't have an option of placing. 6 I don't, I can place it at 7. Okay, so now I have got the minimum distance possible is 3 minus 1, which is equals to 2, which is greater than 1. So now this is our new max. Okay, cool. Can we make it better? Can we make it better? Let's try. Okay, till now we were able to maximize the minimum distance as 2. Let's now try to use a distance of 3. So 1 2 3, I'll place it at 4 this time. Now the third ball, I have to make sure it's more than 3, right? It's more than 3. So now so what would be more than 3? So 4 plus 3 is 7. I can place it at 7. Cool. Now I am getting a minimum distance of 3. Okay, so now my answer, initially it was 1, then it was 2, and now it's 3. Okay, Can we do better? I don't think we can. Because after 4, we directly have the option of 7. Though it's more than 3, but where will you place the third ball, right? So this is the answer. This is the answer we were looking for, 3. I hope the problem statement is clear. Let's look at the problem statement again. So see, yeah, the answer here also is 3. I hope I was able to make you understand what it means. Now, coming to the solution. So, always remember, if you see any question which says minimum of maximum or maximum of minimum, you can start thinking in the binary search direction. Now, why I'm directly coming to the conclusion of binary search, it's something you'll get a hang of as you go on solving problems. But this is a binary search problem which is very evident from the simple statement, the minimum of maximum. Okay, fine. Let's try to build the logic around this. So we are given an array which says 1, 2, 3, 4, and 7, and m equals 3. Cool. Okay, so we can take low as 1. Okay, because we are searching over a range, right? We are searching over a range of days. We can take high as the max value of our array. Cool. Now there are two things to it. You can either take the max value of the array, or you can take the difference of max value of array minus min value of array. Now why? Because look, since this array starts from 1, but it doesn't necessarily needs to be the condition. This can be 1000 and this can be 5000. So since we are iterating over a range, we can also keep it as like 5000 minus 1000 to have the maximum value possible. Okay, cool. So just for ease of understanding, for now I'll just keep it as max of array. Okay, now coming to the logic, how does usually binary search works? Okay, so binary search usually works as when while low is less than equals to high, we calculate mid, apply some logic. If our mid satisfies the logic, we take it as a potential answer, else we discard it and move our high or low pointers. Okay, this is primarily it. So we'll try to do the same thing here. You know what, let me just clear the board really quick. Okay, cool, fine. So let me declare the array here again. Sorry, not 7 3. Okay, so let's say I have got the mid value as 3. Okay, so now let's check if we can place all the balls at minimum of 3 or more than 3 distance. Okay, so how would I do that? Let's say I'll maintain a last position at 0. Okay, and I'll start the loop I from 1 to n, where n is the size of the array. Okay, so when I equals to 1. Cool. So is 2 minus 1 greater than equal to 3? That is position at I minus position at LP greater than equal to mid. Okay, so here this is not true. We'll move forward. Is 3 minus 1 greater than equal to mid? No. Is 4 minus 1 greater than equal to mid? Yes. If yes, we will increase the number of balls we have. Okay, so we'll also initialize balls as 1, because of course we'll place the first ball at position 0, so we'll increase it plus 1. Okay, now since we have already placed, like we are able to place a ball here, what I'll do, I'll update my last position to this index. So this is 0, 1, 2, 3. Okay. Now, is 7 minus last position, which was 4, greater than equal to mid? Yes. Again, I'll increase my balls counter, which will be now 3. Okay. So here 3 will be our answer, because now we have reached the end of the array. So this is pretty much the logic. Now let's go and code it out. Okay, so I'll first, as I said, I'll just sort my array. Start our code. First, let's of course sort it. Now since it's sorted, let's declare two variables, low comma high, and let's take position at 0 comma position at let's calculate len of length of position, so position at n minus 1. Well, position is less than equal to high. I'll also declare an answer variable called as 1, and I'll return the answer here. Cool. So let's calculate our mid. Mid equals to low plus high. Integer division 2. Okay, now we need to keep a track of the last position and the number of balls. Last position is 0, 0th position, and the number of balls is 1 for start. Okay, let's iterate over our array. For I in range 1 comma n. Cool. So here I'll compare if position at I minus position at last position, okay, is greater than or equal to mid, means it's possible. Okay, so I'll just update my last position to I, and I'll update my balls counter. Cool. After this loop is over, so if the number of balls I am able to place is greater than equal to m, which means it's a potential answer, I'll just put answer equals to mid. Okay, now we have one of the potential answers. Now we need to see, can we maximize it? Because our goal is to maximize the minimum distance, right? So I'll make low equals to mid plus 1. Else it's not possible, we need to look for a lower number. I'll just say high equals to mid minus 1. And yeah, that's pretty much it. That's the code. Yeah, I think the code looks good. Yeah, one more thing. I kept it at position as 0, but we have to make it as 1 because of course we are trying it over a range and not the number position. So keep the low value as 1 and the high value at position as n minus 1. Let's try to run it. It's accepted. Cool. So yeah, this is the solution. Please do let us know in the comment section how you feel about it, and do like, share and subscribe. Thank you.